Okay, so 5.2 exponential functions. This will be day number 4. In day 4 video, you will see one more problem, how we solve exponential equations, and then you will see the all-important application problems. Okay, so let's get started. All right, so from yesterday, you learned how to solve exponential equations, and the biggest thing to remember is that you want to make sure you always make the bases the same first. In some cases you might need to make one base the same, in other cases you might need to make both bases the same. So if I take a look at letter D, what do you think? What do you think the bases are going to be if you were going to try to make them the same? Think I got a 27 and I get a 9. Hopefully you're saying that you're going to have to change both of them, and both of the bases would be changed to a base of 3. So 27, rewrite it as 3 cubed, tack on the 2x plus 4. 9, rewrite it as 3 squared, and then tack on the 4x. Okay, do a little cleanup from here. I know when I have exponents right next to each other, I need to multiply them. So there we go, I've multiplied them. Now think, the bases are the same. I'm allowed to drop the base and set the exponents equal to each other. And voila, all I have to do is solve for x, and I get x equals 6. Okay, so understanding, make the bases the same, go from there. I think you got it. Alright, so example 3. Take a second, read this to yourselves. We're going to do this in baby steps. In the first one, I'm going to give you the equation, right? I'm telling you, use that equation to solve this problem. In the next one, I just give you a situation or a scenario, and you have to come up with the equation on your own. So think about the baby steps. I'll give it to you in the first one, show you how I did it. In the second one, you're on your own. So if I look at example 3, it says, notice that a large household appliance loses 1/5, so key, loses 1/5 of their value each year. The current value then can be modeled by that function that you have there. So what I'm going to do is I'm going to write that function there. Notice v sub 0, that is your initial value. V sub t is obviously the value after all is said and done. But where does this 4/5 come from? What I want you to put in your notes is that 4/5 is always going to represent the amount that is left of whatever object it is, right? Notice it says it loses 1/5 of their value each year. So that means that 4/5 of their value is left, right? It's always what is left that goes in the parentheses. Obviously, the mistake I see all the time is they want to put that 1/5 in there. Remember, it's the value that is left that goes in there. From here, very, very easy to solve. I asked you, look at the question, how many years does it take a washing machine that costs $625 new to depreciate to a value of $256? Obviously, the 625 goes in for v sub 0. That's the cost now. I asked you how long does it take to depreciate to a value of 256. That obviously goes in v of t. So plug that stuff in here. What happens? I have absolutely no idea. This is what you should be saying. I obviously know how to solve this algebraically. But you should be saying to yourself, I have absolutely no idea how to solve this algebraically right now. So what I need to do in order to solve it, well, I'm going to go to my trusty graphing calculator and I'm going to do y1, y2, and I'm going to find the intersection. So go to your graphing calculator, 256 in for y1, that right-hand side in for y2, manipulate your window, find the intersection, remember second the button trace to find your intersection, which is number 5. And I think when you do that, you should get approximately 4 years. Okay, next one. Okay, so now here is the scenario. You're going to have to write the equation on your own. So take a second, read that to yourselves. I'm going to go a little bit quicker in this one. So, okay, I've read it. I understand the mound loses 1/5 of its height every month. Be careful, it's in months now. So it looks like I would set up my formula like that, right? If the mound was 25 centimeters to begin, so that is your V sub 0. How long until it becomes less than 16 centimeters high? So there is 16. 4/5 is the value that you have remaining. So hopefully you're okay with that. How do I solve it? Again, y1, y2, find the intersection. I'm going to get 2 months. Second part though, if the mound were allowed to deteriorate further, find the height after 3 months. Okay, so now I'm trying to find the height after 3 months. Remember, it started at 25 centimeters. It has 4/5 of its value left every month. After 3 months, I don't need to graph this. This is just a simple calculation. I get 12.8 centimeters. Okay, so we saw one more how to solve exponential equations. We then saw the applications, and good job.